Hey guys, did you miss me? In chapter 1, we're going to talk about limits, and limits are really just a fancy way of saying that we're looking at the y values on the graph. So one way is to look at them graphically, and another way is we can look at them by plugging and chugging some numbers and seeing what happens when we get close to a particular x value. So the informal definition is, it says that as we get closer and closer to a particular value for x, that the y value gets closer to some value, some arbitrary value, and we're going to call it L. So here in this definition, we see that c is an x value, while y is an L. So if we're looking at it numerically, we can start testing numbers. And of course, the easy way to do this is to put this equation, or this expression rather, into your calculator as y1. And then we're going to go to the table and we're going to fix it so that the table will give us these values. Now, after you get this into y1 in your calculator, if you go to your table, actually after you get that in there into y equals, you're going to go to your table set, which is second window. And you're going to select for the independent for it to say ask, not auto. It's probably on auto right now. And then when you go to the table, there won't be anything in the table, but you can type stuff into the X column. And so you can specifically type these numbers that you see in the table right now. And then all you have to do is fill in the Y value for them. So on this problem, since X is approaching 2, we're interested in what's happening on the graph of this as we approach 2, and so we're going to look at some numbers from the left that are getting super close to 2, and then after we've looked at those, we'll look at some numbers from the right side of 2 as we get super close to 2. So I want you to type those into your graphing calculator, and you're going to round your answers to 3 decimal places. You should get the following. And so what I notice is, as I get closer and closer to 2 here in the center, it looks like I'm getting more 3's repeating in that decimal, which leads me to believe that the limit is approaching 1/3, because 1/3 is 0.333. And if you notice, over here, I decided, what if I factor it? So currently, I actually don't even know that I can't put in 2, but the minute I factor it, I go, oh yeah, I can't put in 2 because it would cause that denominator to be 0. But if I cancel these out, then I'm left with just 1 over x plus 1, and I can put 2 in for that, and I end up getting 1/3, which confirms what I was getting over here in the table. Now, if I actually look at the graph of this, and I can tell from this rational polynomial function right here, I know that I'm not allowed to use 2, but because it crosses out, I know I get a hole at 2, so there's simply a hole there, not an asymptote. Remember, on these rational polynomial graphs, when you have these two numbers that you can't have on the bottom, they'll either give you an asymptote or a hole if the top and bottom cancel out together. So that's what I'm getting there. So what that means is that the graph looks like, it looks like a rational polynomial graph, so I get those little L shapes in those separate sections, but notice I actually do get a hole at 2. And you can see this on your graphing calculator when you graph it. If you turn your table, so go back to your second table set and turn your independent variable back to auto, and then go to table, and what you notice in your table is that you get an error at 2, but it's defined everywhere else. So you're getting that hole at 2. Okay, so now when I look at the questions below, I'm using the graph below letter D, and I'm looking at what's happening. In this particular case for letter A, I'm looking at what's happening as I approach -2 from the left, and here's how I tell, oh sorry, no, as I approach -2, just kidding. So I'm looking at what's happening as I'm approaching -2. So I'm coming and I'm looking here at -2, and I notice, oh, well from the left side, it's getting up near 2 if I swoop in from the left. But if I swoop in towards -2 from the right, it hits 0. So for this one, it does not exist. And we just use the abbreviation DNE for does not exist. I have to stop and see you in the next video.